it reminded me of something that I read a while back when I was getting into AI. AI or machine learning style like programming is different from, or departs from traditional programming in that for traditional programming, you define the rules and the input. So you define the rules and then you provide input, and then you'll get like the machine produces output, right? But with this kind of stuff, you give it examples like input, output, like expected output, and then the machine will figure out the rules for you. Sometimes there's like a lot of rules that we don't fully understand, or it might just not be feasible for us to figure out, right? Like, and so there's this type of problems which I feel is just AI just solves the best, and it might just be the only way to solve a lot of these problems.
Welcome to the /podcast, where we lean into the future of IT by inviting fellow thought leaders, innovators, and problem solvers to slash through its complexity. Today we have with us Azriel Alvarado. Did I say that right, Azriel?
Yep, that's right.
All right. Azriel is a senior software developer, Android and Kotlin enthusiast, master tinkerer, and really good at not reading documentation and learning things the hard way. Wow. We must be related. I think I'm the same way. I don't like reading documentation. I like tinkering myself. And then when I do read the documentation, I'm like, oh man, I wish I'd read that a month ago and not gone through that whole path. So,
Oh yeah. You can. What is it? The saying is you can save 6 hours of debugging by reading documentation for 5 minutes, something like that.
Yeah. Nah. Well, welcome to the podcast, Azriel. All right. So, what we're going to talk about today, I know you had a somewhat recent experience. This is again our May. We're doing a lot of stuff with AI this month. We're calling it our May I initiative. I wanted to talk about. I know you were one of the very early people to kind of just dive in with AI in general here at Caliberty, and just doing, like you said, you're a tinkerer. You were tinkering on your own, just building something. You found a problem and you wanted to solve it, and you're like, let me do it. So tell us a little bit about like what was the problem at hand that you were trying to solve with the solution you built?
So my girlfriend is really good at like identifying songs which fit moments. So I'll be doing whatever, and she'll be like, "Oh my god, this song is like just like this moment." And I'm like, "Oh wow!" And so I look at the lyrics, and it's like spot on. And so I thought it was pretty cool. And um, it came a time where I wanted to like kind of do that myself as well. And so I was like, "Man, how can I?" I was at the time also interested in AI, so I was like, maybe I can use AI for this, because I found myself like asking ChatGPT sometimes, like, what's a good song for this situation or whatever, or like thematically similar songs to this or that or the other. And so I decided to write my own tool for doing that, but with my own playlist songs, because ChatGPT just gave me like really generic songs, and so I wanted to kind of like have something that would do the same thing but with my playlists. So I also really wanted to write like a command line interface tool. I've been wanting to write one of those for like a long time, because I just love the way that the UI looks in the command line. So I built the command line tool, which will allow you to load your songs from a playlist in Spotify. It'll also do some web scraping to like pull the lyrics for the songs, and then it will use a encoder, um, which is a part of a large language model, um, which is used to quantify the meaning in text.
Okay, so I see you're trying to find songs. What kind of tools did you get yourself into when you're starting to build this solution? Like what did that even look like? What were you digging into? What were you reaching for as far as tooling?
So in my case, I used one called Google's Universal Sentence Encoder.
Mm-hmm.
So basically, you feed that thing like some text that can be a sentence or part of the lyrics or whatever, and it'll like give you, I think it's 512 dimensional vector. Um, which represents the meaning of that whatever the text you gave it. And so it would encode that. It would store it in a vector database, which is basically Postgres with PG vector extension, and it would load up my songs, load the lyrics, the meaning of the lyrics, the quantified meaning of the lyrics, and embeddings, and then I would feed it like user input, right? That'd be like I don't know, some astronaut is lonely in space or whatever. And it'd be like Major Tom. And so that was like kind of the idea behind it, and it actually worked. Like I got it working. Um, and after a lot of like pre-processing, that because the lyrics thing is like kind of tricky. At first, I was like, oh, I'm just gonna plug the lyrics in this thing, and it's gonna give me the meaning, whatever. But it turns out that lyrics can be like really weird.
Well, I got so hold on. I've got a challenge. Do you think your girlfriend will listen to this episode? Because I'm going to challenge her
I,
expertise here a little bit.
Yeah, I'll have her listen to it. Yeah,
Well, I don't mean like I'm better at it. So when you explain that, it's like, have you ever seen the movie City Slickers?
City Slickers.
It's like from a long time. There was a scene where like these two guys are supposed to be like Ben and Jerry, right? And it was like something in Ira or something. I don't remember their names, but like the the thing was, he was like, oh yeah, my brother here can name the best ice cream to go with any meal. Just try them. And then they would name a meal, and he's like, oh yeah, scoop of chocolate, scoop of vanilla. And they're like, yep, that's right. And like, wait a minute. Come on. All right, give me an example of like how your girlfriend is good at this like give me some context here. Is this true, or is she just making it up?
Yeah, no, I see what you mean. Like, because sometimes I have my same doubts with like AI, right? Like, it'll just give kind of like generic answers, right? We have like cats, and one of them is like really mean, and so I think it was she mentioned she did something crazy, and she was like, "Oh, that's like this Primus song. I don't know if you heard Primus.
Well, of course.
Um, it was Tommy the cat from Primus. So that one was kind of like an easy one. That's the one I remember the most because it was easy. But I promise you, there's harder ones.
All
So
right, all
I
right.
promise
No,
you, there's harder
I
ones.
appreciate just the fact that she would like recommend Primus is impressive to me. That okay, all right. I'm she can be an expert. We will accept her testimony in this court as an expert witness. Okay, all right. So we're building a solution. We're trying to like replicate your girlfriend's talent of naming songs that are perfect for an occasion. And
Right.
okay, so you've downloaded your songs, you've downloaded some lyrics, and you've taken basically the text of the lyrics. You're not doing anything with like sound processing or anything, right? You're just
No, no,
doing the
no.
lyrics.
Just lyrics. Yep.
Okay, and you turn them into a vector. So that's like when we're doing like with documents, we call that's called like an embedding, right? That's
Yep. An
yeah.
embedding. Right.
I know one thing when I was learning about embeddings, I was shocked. Like you would think like, oh yeah, you need this embedding vector so that you understand all the semantics about this and what does this text even mean? And you hear, as you said, oh, it's a 512, you know, element vector or feature vector. And you're like, how in the world do you get all that context and that richness into only like with only 512 numbers stacked up together? It just isn't that's just wild that they can do it with so few numbers actually.
Yeah. I mean, and that's probably like the lower end. I think.
Hmm.
I mean, I think that it goes way higher too. Like you can. I saw one that's like 1,000. But I so far like I've tried to mostly play around with the smaller models mostly because it's easier to like run them locally.
Hmm.
They're faster. Also because I'm a mobile developer, and so like part of what I'm aiming towards is being able to like you know learn how to use these models and then eventually maybe do some fine tuning and load them onto like an app, right? So they can run locally on like a mobile device. I think the smallest ones, some of the smaller end ones are like 250 megabytes, something like that. It's
Man.
still kind of heavy, but
Yeah.
you
I'm not running that on my iPhone. I'll tell you that much.
know.
Well, you're an Android guy, so you wouldn't worry about that. All right, so we've uploaded lyrics. We've created embeddings. We've saved those embeddings into a vector store, and now you're what are you doing at this point?
Right. So now, I just those are still in those are just sitting there in the vector database, and so I take user input. So like I run the program, right, and I prompt the user for input. User inputs, whatever song lyrics, like rock music causes, riots or whatever, revolt, and uh, and then I press enter, and so that the program is going to take that text, it's going to do the same thing to it, so it's going to create an embedding for that text, and then it's going to perform a query on the database, uh, which performs this operation is called cosine similarity, which basically, it's a math, but it basically finds it compares that vector or that embedding with the embeddings of the songs in the database, and it'll find the ones that are most similar, um, which should mean that they have similar meanings, right? So if the embedding represents the meaning of the text, then whatever vector is closest, um, to the vector of the input text should represent, um, text that is most alike, so it's more similar. So that it
Gotcha.
performs that query, and that happens like out of the box. Like you don't actually have to write the code for cosine similarity or anything fancy. Like the PG vector extension in Postgres does that for you. So you just have to it gives you like a special, query command to use. So it does that automatically, and so it'll just give you like, I don't know, the top five matches. And so that's what I return. I return top three or something, whatever. You can give it you can use as many as you want, but I just use three. Um, and so yeah, in the case of my example, it would return Rock the Casbah.
Nice, good song too. So your solution, you stopped short of going, back to like the language model itself and kind of doing the RAG thing, right? Where you search your vector store, get back the lyrics that sound like they should be, and then you send it to an LLM and say, tell me some things about this. You're just using the similarity search as kind of um, a quicker way to get at the information you need.
Right, right. I'm not doing any generation, so I'm not using the other. I'm not feeding it back into the decoder piece of the large language model to have it generate something for me. I'm just leaving it at that because I don't need to generate anything. I already know the song names and all that. So
So it's not so much RAG; it's more like raw.
right, or just R
Just
retrieval
rawr.
or whatever.
It's a pirate. You're not pirating music, are you? No, I'm just kidding.
No,
No, no,
certainly not.
we don't do that anymore.
You don't do that.
That was a long time ago. Nobody does that. Okay, so how did you find the how effective that was? Because I that was my I have done that as well, but I had mixed results depending on different embeddings and whatnot. How was your experience with that?
So, um, also mixed. Like what I found was there's a lot of work that goes into like pre-processing, and like you can make it easier on the model to like do what you want to do if you do the right pre-processing. Like so, for example, at first I was like, oh, I'm just going to feed the entire lyrics, and that's not good, um, because I think it kind of like you get like these watered down, uh, meanings, like embeddings, right? Because they're representing the meaning of the entire song, and songs like an entire song can like touch on various subjects, right? So that didn't work out super well. It worked better when I kind of like split it into lines and, removed like a lot of the stuff that wasn't like a noun or an adjective or things like that. So like filler stuff. They'll have like the yeahs and the oohs and the ahs in there. Like get rid of all that and and just calculate embeddings for each line and then use an average for that. So that would be like the average of all those embeddings. So that worked a little bit better for me. I got better results, and I've also found it's like a lot of trial and error. Like it's not, partly because I'm new to this, so like I don't understand like all the inner workings. But I felt like overall, like fundamentally, it's more of a trial and error process than like traditional programming. Where like I'm like, oh, I'm gonna try this, and I kind of like have a sense of what that might do for me, and then I just do it, and then I'll get different results or measure my results and how they kind of like um, how it performs and all that. So um, but yeah, overall the performance of it at the end, like I was able to make some improvements, but still it kind of struggled to catch on to like the abstract meaning in lyrics, which is very poetic, can be like highly abstract. Um, so like I would sometimes have to, it would perform best when I would like actually include words that would be in the lyrics, right? So if there's a song that talks a lot about, I don't know, plants or trees, and I include the word tree in my prompt, like in my input, then it'll do way better. Um, so yeah, that's kind of what I found.
Yeah, I found like the embeddings they're pretty good at like having like generic meanings, so you don't have to like take the text and say, turn trees into trees. It's not doing an exact like keyword match or anything, but it does develop some semantic meaning. But I found the same thing as you. Like the closer you are to the exact words, the better I found I was able to actually get results out that I would expect. So it felt more like search, like just raw search as opposed to like meaning search over time.
Yeah, it kind of felt like that. Like it's definitely has it's a bit more powerful than your standard traditional searching tools, but it's still like I think that without further fine tuning for the specific case, like the kind of input that you're giving it. I mean, I'm not sure how exactly like Google's universal sentence encoder was trained, but probably not with a whole lot of like poetry. I mean,
Mm,
I'm assuming,
that's a good
right?
point.
So it probably has a hard time like doing that's probably more with like standard sentences, communicate more concrete things. Um, because it's like I said, it's a relatively small model. Like in the context is only like 512, um, you know, dimensions of this vector space or whatever, and so I don't expect it to be able to do like a whole lot beyond something generic. Um, so yeah, that was my experience with it. Um, I also did some fine tuning with some other stuff because I was like, man, I have to do some fine tuning on this to make it more effective. But I felt that that problem space for like the lyrics thing was too challenging for my level, so I did it with something else, like a different problem.
So, like, as you were digging into this, like, how was you know, at first I'm sure it was like, okay, you're a tinkerer anyway, so you're rising to the challenge. But like as you're digging in, like I know it's probably like, okay, where do I even start with this stuff? Like, how did you find that experience of like getting quickly to the information you needed to kind of accomplish what you were trying to do? I mean, there's just so much stuff out there right now with generative AI and all that. Like, did you find that easy to do, or was it hard to weed through everything?
For this part, right? So using the music search, like lyric search application, it wasn't that difficult because most of the work was like really standard programming stuff. I mean, the really where the like AI knowledge came in was in selecting a model. It was in selecting a model and kind of like understanding some minor details of like, okay, well, how do I kind of like set this up with how do I set up like the vector database to support what the model is outputting, right? Which so it was like I had to make sure that the vector database was used like the proper dimensions, like oh, it was 512 size vectors, right? And this model uses outputs this size vectors. I mean, I mostly used Hugging Face. Uh,
Okay.
so Hugging Face has some great documentation on models, and
Mm.
you know. how they work, what they do, what their limitations are. That's the best documentation I've seen so far. I use a lot of ChatGPT. Like I actually really love ChatGPT for educational purposes. However, I also felt that it was like it hallucinated a lot. So it was very confusing. Like that's why, like, I mean, tinkering was eventually, like, in this particular scenario, is like the best way for me, because I was like, oh, man, I don't know if I can trust ChatGPT, and this documentation is like kind of crazy. I don't know what what softmax means right now, or whatever training method, or model architecture really means. So I'm just gonna like start working with it and see what happens. And so that really was like that, just setting up a really nice environment so I could like iterate super fast, comfortably and painlessly, and just like try things out was, the best teacher for me.
So, and I have to ask because I know you do a lot of mobile work, and you said I really want to develop a command line interface. Is this like just to get rid of all of the garbledy gunk stuff in a phone and like just get down to something more raw?
So the main reason was not really related to mobile. I mean, it was just because I just like command line interfaces. Like, just looks super cool. I mean, I just love the way that they like the colors and the text-based interfaces. I don't know. It's just visually appealing to me. So that was the main thing. But also there was some. It is kind of refreshing to to use UI libraries which are way lighter. I mean, obviously, when you're writing like stuff for Android, it's like, there's this huge framework that has like all this stuff, and it's very opinionated in how you're supposed to do things, right? They have like an entire UI library just for for Android, and then they have the framework code and all that. And so with writing stuff on the command line interface, start writing stuff for a command line UI, um, it was a lot more lightweight. I don't know. It was interesting. It was also very imperative. Do you remember like Java Swing for
Oh yeah,
UIs? So
oh yeah.
it's a lot like that, and so it's kind of painful in a way. Like I get why modern uh, user interface libraries are reactive or whatever. Like they're declarative. Declarative
Hmm.
is the word. Declarative instead of imperative. So you just kind of like write what you want on the screen, and then it just does it for you.
Right.
So you don't have to like hold a bunch of references and things like that. And so with this kind of thing, it was kind of like moving back to that previous state, because they don't have anything like that. It's just still like super imperative. Um, and I don't know, it was cool. Like it was like you know, it was kind of refreshing to do something different, mostly.
Yeah, I had done some stuff with command line a while back, and when I learned that there's actually a term for a user interface on the command line, which that is a user interface. You're interfacing with a computer. They call them TUIs, textual user
Oh,
interface, a
right,
TUI. I
right.
thought that was just funny saying TUI. So yeah,
Chewy.
anyway, TUI. Yeah, I had never known that before. Looking back, I mean, now where is your solution today? What are you doing with it? Was that just kind of a little passion project on the side, and it's done now? I'm on to something else, or what's going on?
So at that point, when I realized that I needed to do some fine tuning in order to have it perform better, I kind of like left it at that and tried learning fine tuning. Started learning fine tuning, and my plan is to like, once I kind of like learn fine tuning and then kind of like learn some more of the underlying concepts behind how that thing is working, then I'll go back to it and make some improvements with that new knowledge, right? Like maybe choose a model that works better for that particular use case based on knowledge of how the models work and what they're best used for, depending on their architecture, things like that. And then maybe do some fine tuning specifically for that case. It was just like fine tuning for that case, like it seemed very difficult, because it's not a trivial task, right? Like teaching a model to understand like abstract meaning in lyrics or poetry, I think is not trivial, especially for like a beginner. So I
I
went
think the
on.
trick is like is kind of like what they call like labeling the data. So you have an input, and then you want the model to have an output based on that. And so you have to have like you have to be able to tell the model this is what I would want you to output so that it can learn, like that supervised learning loop. That's probably the hardest part, is coming up with like all that labeled data for things like that.
So like there's that question, right? It's like, okay, so what should my data look like? And so sure, I guess I could be like, I could give it examples of songs. I could give it the input, that I want, like a text. But well, that's the thing, is that that's not what the thing is doing. Like I couldn't use as my examples like input text, like prompt text or whatever, and the output like the name of the song, because the model is not really doing that. It's just encoding meaning.
Right.
And so I would have to do something like, I don't know, summarization, probably like a summarization task. Like I'd have to give it poetry lyrics and then have it explain it, like, summarize it into more concrete terms or something, right? Maybe doing something like that would kind of teach it, but it's not a super direct thing where it's like, oh, classify, right? And so for a classification task, like it's very easy to imagine what kind of examples you would need, right? So usually, that's kind of like what you start learning with. So it wasn't clear to me exactly what kind of examples I should use to train the thing. And also, it kind of became evident quickly that I would need to, it would be kind of difficult to get that data in the first place, which is
Hmm.
something that causes a lot of resistance. It caused a lot of resistance for me to like get into fine tuning in the first place, because like I was kind of like stalled for a while because I was like, man, I really want to keep on working on this project. Um, and then I was like, man, okay, well let's try with like this kind of example. I asked ChatGPT like, oh, what kind of examples do you recommend for training this model to do this? And it was like, okay, well you can do this and this and that and the other. But the examples were kind of like complex, and I was like, all right, well, how do I get like 10,000 examples of this? And then I was like, oh man, well I guess I could use Mechanical Turk, Amazon Mechanical Turk. Have you heard of
Hmm.
that?
Hmm. If you were going to do it over again, if you were going to take another run at this project, is there anything like, based on now that you've done more and more research, like I'm going to start fresh. What are you grabbing for? What technologies? What tools? What are you doing if you're going to take this on again?
I'd learn a little bit more about the models before choosing one of them, but hmm, I would definitely do more pre-processing. So I did some, but I think I would do a lot more. I think that might help. Let's see. I think
And
the
by that,
tool.
what do you mean by, like, kind of tell me about the pre-processing? Like,
So
what would
like
you do?
there's some more. There's like some tools out there. Like there's some libraries for natural language processing where you can like, it makes it really easy for you to like extract. To make it even easier without having to do fine tuning, I would probably have it like extract even more. So like maybe even just take the entire lyrics and then just extract like, certain keywords or nouns or adjectives or something, and then do some pre-processing there just to help the model as much as I can, since I'm using a really generic one. Or I would use a more powerful model. So yeah, because I really just went with like the first one. The first, like I looked into two. I was like Distilbert or Universal Sentence Encoder. Those are the two I
Hmm.
looked at. So I would have probably taken a little bit more time to look at what other options there were, and then and chose one a little bit more appropriate for the task. I did not regret using a command line interface, even though it took me a long time to like get that running, but it was worth it. 'Cause it looked really cool, and you can like I was able to like use like, how when you open some like command line tools, like it'll pop up like the logo and like text art, like
Hmm.
yes, I was able to do that, so that was cool. That was worth it. And yeah, I mean, overall, it was like a learning project. So like, I know that there's tools out there which make a lot of this a lot easier. Like I think that it's called is it LangChain?
Hmm.
LangChain. So like the other day, someone else from Calibrity was doing like a demo on something they built with LangChain, and I was like, man, she did everything that I did in like 2 lines using this library. And so like I was like, man, I might have used that like if I was actually trying to like just get something out super quick. But part of a huge part of the purpose of this project was actually for me to learn. So I think I would have just done the same.
I was I was struggling with like you talked about how do you break up the song? Like, do I do it by stanzas, and then should I repeat the chorus multiple times? Like, there's a lot to think about. So I was new on this forever. Like, how do I chunk this, the verb, right? How do I chunk this thing up into small chunks and make it so that it's not too big, not too small, right, that kind of thing. And I'm like, wait a minute, I've got an LLM here that understands language. I just fed the whole darn thing to the LLM and said, break this into chunks. And it did it for me based on its understanding of language and the nuance and whatnot. And it actually did a pretty darn good job. Now, I ran into trouble when I had like really big documents and stuff, but I was able to work around that. But like, I thought that was a really cool, like, why am I messing around with this? Why don't I this thing understands language really, really well? Let it break this thing apart. And that was like kind of a breakthrough for us. And well, for me, when we were working on this thing, like so I didn't have to, fiddle with it so much all the time. Yeah, just throw it at the language model, let it break it apart. And it did a pretty good job. And then what I told it to do was not just break the text apart, but like it's kind of you talked about like get rid of the oohs and ahs and the what we call stop words in natural language processing, get rid of all that stuff. So it streamlined that. And I said basically optimize the chunks that you extract for inserting into a vector database. So it knew to do all that, get rid of all the fluff, and then I could just the semantic stuff, the stuff that would actually encode and actually provide meaning. It left that, and it was actually really cool. It worked out really well. So I thought that was a lot of fun. And I also I took it a step further. It's probably a little expensive to do it this way. When we have a query come in, like when the user types things, I send that to the language model. I say, this is the query they gave me, the prompt they gave me. I need to use this to search a vector store. Can you basically rewrite this or beef this up for me, so to speak, so that it's best suited for searching a vector store? And it did a pretty good job of that too. So yeah, it was pretty cool.
Yeah, like and that's kind of like I think that's generally it's kind of like one of the challenges with, or well, probably one of the biggest challenges in that part of RAG, right? Or the part that I
Hmm.
touched on, and what you just mentioned is like chunking, right? How do you chunk this stuff, right? Like this complex input or whatever text, like how do you chunk it so that it has what I need it to. So that we can encode or quantify what we need to quantify, or we can access it easily, like query through it easily, things like that. So definitely chunking is a challenge, and also I think that it's funny that you mentioned that. I think that also kind of it reminded me of something that I read a while back when I was getting into AI. I started like this book, and then the book just like overwhelmed me a bunch. But this is one of the things that I remember from it, and they were like AI or machine learning style like programming, um, or engineering or whatever you want to call it, is different from or departs from traditional programming in that for traditional programming you define the rules and the input. You define the rules
Hmm.
and then you provide input, and then you'll get like the machine produces output, right? But with this kind of stuff, you give it examples like input and output, like expected output, and then the machine will figure out the rules for you. And so, like, I think there's a lot of challenges where, like, I've kind of like come across this like a bunch, right? Where I'm like thinking about something or some kind of problem, or in your case, like, how am I going to chunk this or whatever? And sometimes there's like a lot of rules that we don't fully understand, or it might just not be feasible for us to figure out, right? Like to write down all the rules for what
Hmm.
like processing an imagery or determining
Right.
what a dog is. Like, oh, if this pixel is in this position, like it's not a dog. If it's And so there's this type of problems which I feel is just AI just solves the best, and it might just be the only way to solve a lot of these problems because we can just have it feed it real life information or like a bunch of these examples and data, and it'll come up with the rules for us. It'll do it in like a really obscure way.
Hmm.
Like it's kind of like we
Absolutely.
don't even understand what rules it uses entirely, right? But it'll come up with those rules when we have to
Yeah,
make
I
it to
think
find.
you bring up like the identify a cat. That's one of the big things that like people teach with AI is like image recognition, like trying to find a cat in a photo or something like that, or an apple and an orange, those kind of use cases. But like the what's interesting, I think that's a stepping stone. People kind of lose sight of like just getting it. to recognize a cat, that doesn't really enrich human beings' lives, right? Like you and I if I see something, that's a cat, right? Like I'm pretty good at that. I don't need a computer to tell me how to find a cat. However, if you take it to the extreme and let it and turn it loose on bigger problems that we don't have the perception to be able to understand, then we get really interesting findings like the I forget the name of the antibiotic, but they found like an antibiotic that was um that it could kill MRSA or whatever, right? One of the resistant strains of bacteria. We would never have, they have no idea how it figured it out. It saw connections that the model saw connections that we never would have picked up on. So that's where you want to use, like, have the computer do the computer thing, right? Like, I don't need you to show me what a cat is. I can do that. You go find all of the interconnections of between like chemicals and all that stuff that's going to save people's lives. That's what the computer can be good at that we just can't do. We don't have the ability to do that. All right, Azriel, this has been fantastic. Up next, we're going to do the segment of the show that we call Ship It or Skip It.
Ship or skip. Everybody, we gotta tell us if you ship or skip.
Do you think RAG really has a future in the generative AI world? Do you think is it here to stay, or is it just a passing trend?
Like a week after I kind of started this, they're like, oh, now it has 1 million tokens in its context window. And I was like, man, that kind of like makes RAG like obsolete. I mean, not entirely obsolete, but like you can just you don't need RAG in a lot of situations now that we have that. Assume, I mean, unless you like want to save on
Right.
money, right? I think it comes down to like a cost thing. Um, but as like you used to actually need RAG to be able to do certain things because like the context window of the models was just limited. So you had to like somehow you had to fetch some of this prefetch some of this information to kind of like feed it, and as part of the context, so that the AI could like read from it instead of like having the AI know about this huge information base, which is way larger than the context window. But now for most cases, you can just like plug it into the query. You can give it an entire code base or like a huge document, and then
Mm-hmm.
just or we could probably fit our entire Calibri wiki in 1 million context tokens, right? And then just have it, give it the prompt right after that and have it do that. So I don't think it's needed anymore to enable a model to do those kinds of tasks, like being augmented with information, but it makes it cheaper for now. Um, so yeah, I think that I would not invest too much time in learning RAG at the moment beyond like the fundamentals, because I feel like um, yeah, it's going to change probably moving forward, and even if it doesn't change, like it's going to be super abstracted at some point, or like
Yeah.
with LangChain, right? Like, oh, now it's like
Mm-hmm.
2 lines that you can just do the same thing in, right? So I feel like it's not. I think it's good to know, but I think it's gonna the industry's changing too quickly for me to be like, oh, I'm gonna become a RAG specialist.
Okay. So you're skip it ish. Skip it ish. So I think that's a
I would say skip
technical
it ish.
term.
Yeah,
Skip it ish.
definitely skip it
Yeah.
ish. Skip it ish.
I'm with you on that. I think the context window thing is becoming, it's making like RAG somewhat obsolete. I still think it's probably going to have its place, like as you said, as a cost saving mechanism. Right now, I'm old enough to remember back in the day when it was like, hey, I only have so many minutes on my cell phone kind of thing, right? And like, and that's how we are right now with these generative models, right? You're having to pay by the token, and so you just every single request. But now it's like I don't pay for extra internet, I don't pay for extra time on my cell phone. So if this becomes more of kind of like a utility, so to speak, like those things have, where you're not doing that pay as you go kind of model. Absolutely, like I think you said like we could upload our whole wiki. I mean, like I was thinking like our handbook, right? That's one of the big RAG like use cases. Everybody says like, oh, you can take your company handbook and break it apart, but let's face it, our handbook's not. I mean, it's not like Tolstoy, right? Like we can probably manage to send it up there and be like, hey, here you go. and just read this whole thing and tell me how many weeks do I get for paternity leave, and it would spit it out, right? So yeah, I'm with you on that. I think it will get there, but I do think that we're going to be with RAG for a little while. All right, so you have a vast experience building user interfaces for users. One of the trends I'm seeing or hearing about is kind of this, and it's AI related, where instead of like giving the user kind of all these widgets and controls and everything for them to go do the things that they want to do, a lot of folks are kind of exploring this idea of like the interface is very simple, almost like Google, right? So you just type in, I want to pay my electric bill, and you just type that in, and instead of having to like navigate through a bunch of stuff and widgets, the AI just figures out like, oh, I see you want to do this, let me go do this thing. What do you think about that concept as a human computer interaction kind of thing?
I think it's really cool. I mean, I'm a fan. I'm a fan. I mean, I think Notion. I use Notion a lot, and like Notion's kind of cool in that way. Like I think it's integrated a lot of that. And actually, like I recently also I bought a printer. It's like an Epson printer, and it came with an app.
Hmm.
And
Yeah,
printer
they're
apps
awful.
usually
They
suck. Like
usually
they're
are.
usually terrible. I hate printer apps. But it actually like so it had the normal UI, right? It has like the traditional UI. Um, but it also had like when I was setting it up, it actually opened a chat interface. And I was like, wow, it was really surprising to me that out of all applications, like printer apps would be one of the first that I would see like integrate this stuff, you know? So it was like a chat, it was like a chat bot. And um, like it was like, oh, well, so, do you want to set up the printer, whatever? And like, yeah. And then it would give me the options. And then it would all be this textual interface, and they're like, all right, so choose in this list, what the printer is, and I'm like, oh, bam, like okay, I'm gonna set this up for you now, whatever. Please press the button on the printer, and then I'll do it, and I'll be like, yeah, I just did that, and they'll be like, okay, doing this now.
That's cool.
So the whole setup was text based. It was like a chat, and I thought it actually worked really smoothly. Like I really liked it, and it worked well. So I so far the use cases that I've seen for that, they work well, and I think that's one of AI's strengths, right? Is like providing that um, that like a textual interface that feels very natural. Um, and I mean, I use ChatGPT a lot to like I have full conversations with it, and when I'm like coding, I can tell it like kind of what to do, and most of the time it's pretty accurate in interpreting what I want it to do.
Wow.
Even if I'm like super vague, it'll be like, oh, I know you were trying to do this, right? So I feel like that's something that overall
Hmm.
models can do really well. Is like interpret your intent. Like I've never had issues with that, and so I think that from user interface perspective, like most of the time that's what you're trying to figure out, right? Is what is the user trying to do? What do they want to do? Like click this button to do this, right? So I think that that's a good use case for it. Obviously it's not going to eliminate like the other principles that we already have. I mean, you're always going to need some kind of um, more visual buttony user interface, because first of all it's probably way cheaper to do that. I mean, it's probably like, I don't know, how much more expensive would do you think is like triggering a user action via
Mhm.
text, via a model versus like just pressing a button? It's probably like
At least, yeah,
10
I'm
times more
sure
expensive
it's
or
pretty
something,
pricey.
right? I don't know, at least, yeah. So um, and there's just stuff that's always going to be simple, right? Log out, log in. So I think it's always definitely going to be some kind of hybrid, where you have like your base interface, and then for certain functionalities you'll like search stuff. I think it's definitely going to
Yeah,
impact
yeah.
search UI design for sure, like 100%. Search UI design, support, kind of stuff. That kind of stuff is definitely going to be
Okay.
integrated. So yeah, definitely.
Yeah. I do like the idea too. I'm kind of a minimalist when it comes to like interfaces and stuff, and I like that. I like the idea of the purity of it, so to speak, right? But I know my experience. Like, I don't know if you've interacted with some of these chat bots where you're like, I need to do X, and you're like, oh, I understand you need to do Z. Here's the options for how to do Z. Hold on a sec. Wait, I said X. Oh, Y is very convenient right
Yeah.
now. Have you tried it on our website? Like, what are you? And the last segment of our show that we do, it's really important. Lots of, right or wrong answer questions. It's high stakes. So you're gonna you're gonna want to be on your game for this. Okay, you ready to go? All right, we're doing the lightning round.
It's time for the lightning round. Rapid fire, don't slow down. Answer quick and make it count. In this game, there's no way out. It's time for the lightning round.
Godfather or Star Wars?
Star Wars.
What's your ideal outside temperature?
26 degrees Celsius.
I have no idea what that means. Just kidding. 26 degrees Celsius. All right. Okay. Now I got to go convert that. I can maybe ask ChatGPT to do that for me. I'm in America. Would you eat a day-old taquito from 7-Eleven?
No.
Polka dots or stripes?
Stripes.
Have you ever been to Africa?
No.
Is double dipping at a party ever acceptable?
No.
And finally, what is the place you most want to travel?
Argentina. Yeah, Patagonia.
All right, Azriel. Well, that wraps up this episode. Thanks again for coming on. I really enjoyed the chat and learned some cool stuff. And I'm going to have to go out and try out how if I can figure out what song is the best song for this moment in time. I don't know if I'm pretty good with movies, songs. I don't know, but I have to try that out. But yeah, again, man, thank you so much. This was great.
Yeah, sure. Thanks for having me, and I'll definitely reach out once I have my app finished.
Well, thanks everybody for joining us today. If you'd like to get in touch, drop us a line at @caliberty.com. See you next time. The / podcast is created by Caliberty. Our director is Dylan Courts, producer Ryan Wilson, with editing by John Corey and Jeremy Brown. Marketing support comes from Taylor Blessing. I'm your host, James Carman, and thank you for listening.